One of the trickiest topics kana muri ku Form 1 in the transition from grade 7 to Form 1 is algebra. And the reason why algebra is tricky is because it's unfamiliar. So when we look at algebra, the moment patinotanga ku replacer, typically in algebra tinenge tichi replacer an empty box with letters, and of course we know that my letters are they are usually x kana kuti y. Why ndati tiri kureplacer that empty box? Because tiri ku grade 7 tainzi 3 plus empty box is equal to 6. Question yoti what number is inside the empty box? So kana taku algebra Form 1, we are going to replace this empty box with a letter. 3 plus x is equal to 6. Then swashanzi solve for x, and I would solve the equation to find x. Why ndichitangira panapa? Because today I want to teach polynomials, long division. But why is it that tangira could this scenario of transitioning from grade 7 to Form 1? Chandinoda kuti mujaire, chandinoda kuti muzive kuti maths munodziita through association. Teacher wangu akandidzidzisa mathematics, and I think this teacher is the one I give the most flowers for teaching me how to think mathematically, Mr. Charumbira Kukomere High School. Vakati ivo, when you are learning mathematics, your mind is like a spider web. Andika? Kurauti pane maburu akawandisa, there are many empty spaces. When you learn, it's more like uri kutora zvinhu uchita deposit in those empty spaces. Why am I saying this? Association yakakosha kumaths. And association taishandisa in this case of algebra. Isu tichidzidziswa takanzi kana ma x nema y akunetsa, imagine kuti it's a number. Saka associate what you already know, because we understand numbers takazviita from grade 1 to grade 7. Associate that with what you do not know. So sometimes when you want to understand a mathematical concept, tangira pane zvaunoziva, then work with zvaunoziva until you get to what you do not know. What I'm saying is going to be material in today's lesson, because we want to look at long division, and the principles which govern this long division, they are the same as the long division yamakadzidziswa pa grade 3 mukaita grade 4, maybe kusvika grade 7 mukasiyana nayo. So I want to take you aback, dakukudzoserai ku primary ku long division, toi revise, toi dzumburudza, then totora that knowledge to associate with how we do long division. Now tava ku advanced level mathematics, pure mathematics, takuchita long division kwete yema number, but long division yema polynomials, yema algebraic expressions. So where we are going to begin, let us say we are given this situation, and you can note kuti handisi kunyora in my traditional white color, because ansandatanga kunyora ma notes ndichiri kuintroduce my topic. Let us say we are given 3, which is supposed to divide into 66. Of course, we also teach a principle in mathematics, yokuita follow the path of least resistance. This principle inoti always find the easiest method available and use that. Saka ku solve this question, deno yanga yakangonyorwa yakati 66 divided by 3. I know most of you would just say 66 over 3. 3 into 3 it's 1, into 6 it's 2, into 6 it's 2, to make our answer 22. But today, let us go back to long division. Tuone kuti taiita sei. Saka long division manje, let me do this. Saka I want to drag this passive Shona so that you can see. long division yatakadzidziswa kuprimary zvainzi tinoti 3 into 6 ndi 2 tobva tati 2 times 3 towana 6 tobva taisa minus panapa todai tobva tati 6 minus 6 ndiani ndi 0 then we bring down 6 3 into 6 ndi 2 2 times 3 ndi 6 subtract 0 saka the answer here would be is equal to 22. You can go further, remainder 0. So zataita hapo 3 apinda mna 6 yatawana iyoyo 2 yazo multiply 3 ikadzoka zvaka subtractor tikaita bring down 6 3 akapinda futi mna 6 yatawana 2 ika multiply 3 tikazoti 6 minus 6 tikawana remainder of 0. It's the same principle, the same method ndoyachashandisa when we are now doing the long division of polynomials. So I'm going to bring you back to this, but for now let us now write our notes. So what is going to be our first note? The long division. So the long division is a technique which is made up of 4 component parts. Let us write that down. The long division is a technique that is made up of four components or 4 component parts. So I'm following what our course reader is teaching. I'm following the instruction of our course reader, but of course I'm going to simplify it further. So what are these components? Saka we already know them. What we are dividing into is called a dividend. Then what we use for the division is divisor. Answer yatinowana from division inonzi quotient. Then we do our operations. Kana kuno kukazosara kuine a number which is smaller than the divisor, tinenge tava nechi ndo number yacho yatinoti remainder. Because of course technically remainder yagoni kuva hombe kune divisor. It won't make sense because ikava hombe zvoreva kuti divisor inokwanisa kupinda into that number. Saka in all cases the remainder should always be lesser than the divisor. Saka panapa manja chatinge tichiita, it's actually a series of elimination steps. We are going to be eliminating kusvikira either pa remainder or pana 0. So a series of elimination steps. Okay, Saka we want to use an example which we used in our yesterday lesson, using the example from the previous section. And in this example we want to see how long division is done. But before I do that, ngatidzokere kunoko paka question kedu aka. There's something else we want to do. How about yanga iri 3 into 65? Because we are going to have situations in polynomials where we have a remainder. Saka toda kushandisa the model yatakadzidziswa primary to also explain what happens in the case of a remainder. Saka tenge tichiti 3 into 6, that is 2. Tova tati 2 yacho times 3, that is 6. We subtract 6 minus 6, it's 0. We bring down 5. Tova tati 3 into 5, that is 1. 1 times 3, it's 3. Then we subtract 5 minus 3 is 2. But because 2 unoi mudiki kuna 3, 2 uyanenge ari vachi our remainder. And remember that this is our divisor. it is a component of long division. This is our dividend, a component of long division, and that is our quotient, also a component of long division. So that I type up, you're going to see it playing itself out, and it's going to be beautiful, I promise you. Okay, so we want to do our first example, but before I do that, just want to remind you, I also teach O-level maths, as you know, and in most of my paper seta, especially kana tichita ma numbers, I always put this question isa in almost every paper seta isa 4 divided by 2 dot what is this equal to, and isa 2 divided by 4 dot what is this equal to. And in most cases people always get confused there. 4 divided by 2 na 2 divided by 4 msiyano wacho mbori papi. Saka we know kuti 4 divided by 2, that's 4 over 2, which is equal to 2. And 2 divided by 4, it's 2 over 4, which is reduced to 1 over 2. But for the sake of convenience, let me say it's 0.5. So what I want to instruct here, 4 uno uyu ndiye anenge ari dividend. I explained this in my topic ku O-level fractions. I called it the anatomy of a fraction. Then 2 uno uyu anenge ari chi divisor. Then of course answer yatinowana is the quotient. Saka aya turi ma 4 components, of course tasowedzera remainder. They are not unique, they are not foreign. But chakakosha when we are doing long division, because remember takadzidza earlier on, what did we call that? We called it remainder and factor theorems, so you have to remember those. But here now, and hear me well, zvakakosha kuziva kuti divisor ndeipi, quotient ndeipi. Quotient of course it's a result of division, saka munoiwana automatically. Chakakosha kuziva kuti divisor ndeipi, dividend ndeipi. That is very sacrosanct, that is very important. You cannot go anywhere without this base knowledge. That is why tatsanangora tichiti component parts of long division. But ngatisawanza mbambo pachitewe cheshindi. Ngatitei our example yedu. We want to use the example we did in our previous lesson. P of x ndo function yedu, that's our polynomial. It's quatic, x to the power 4 minus 2x squared minus 3x minus 2, let us say divided by x plus 1. I also want to remind you kuti x plus 1 ingeri chinzi factor. That's how you link these to the remainder and factor theorems. Remember that. Saka toda divide zonizo, but ku divide we only use long division. Saka takadzidza long division primary tikakanganwa nezvayo, because tanga tine a better way of dividing fractions. But now tadzosa long division, and ndiyo yega nzira yamunogona kushandisa kuti mu divide ma polynomials. So to do this, we do this. Chitereresa imagine. Maitiro atinozviita, we have to note kuti divisor ndeipi, dividend ndeipi. Divisor ndiyo factor, ndiyo expression iri kupinda mune imwe. Most cases inenge iri of a lower order, mchazozona patishaita ma partial fractions again. Saka divisor yedu x plus 1 iri kuita divide into the polynomial iri x to the power 4 minus 2x squared minus 3x minus 2. There's something we have to do to that polynomial for convenience. Kuitira kuti long division yedu ive simpler and easier. So atinofanirwa kuita apa madzangu, tinofanirwa kuinyora yakadai so: x to the power 4 then instead of kubva pa x to the power 4 toenda pana minus 2x squared, because panapa pajambirwa an order which is the third order, tinobva tati plus 0x cubed, because tokuda kuti titi 4 3 2 1 0 ari mapowers. Saka panapa tine power 4 hatina power 3 ndo yata invenda, but tati 0x cubed because we know kuti anything multiplied by 0 is 0. Saka zvataita izvo hazvichinje value, intrinsic value ye polynomial, zvinongotibatsira kana tichida kusolva. Handisi kuziva kana maona zvataita, I trust maona, but muchazonzwisisa kuti tazviitray in a moment. Then panapa since tine squared inoi takutongoti minus 2x squared, tina x to the power 1 minus 3x, then topesa redu ne constant yedu like this. Mapaona paside panapa rega ndidzokorodze zvatamboita 3 into 66. Ndoda zviita zveseka 1 kuti muone kuti zvoitwa sei. Saka pano tatanga tati 3 into 6. Muri kuona 66 in number, andika yes it's a number 66, but hatina kuti 3 into 66, tati 3 into 6 ndobva tawana 2. Zvatinoita kunoku tichati x inoi into x to the power 4, x yekutanga into x to the power 4, tinowana x to the power 3. Saka ndo zvataita kuno tati 3 into 6, even though number yese iri 66, but tinotanga nenumber iri kwekutanga 3 into 6 tikawana 2. Panapo tatichi x into x to the power 4 tikawana x to the power 3. Then tikauya kuno kutazoti 2 times 3 tawana chi 6. Muri kuzviona? Saka tichaita the same thing kunoku, tichati x cubed times x tinowana x to the power 4, but tichati futi x cubed times 1 towana plus x cubed. Saka chichapinda mna x to the power 4 ndi x chete. Yatinenge tawana x cubed icha multiplier every component, every term inside the divisor, the factor. X cubed times x, x to the power 4, x cubed times 1, x cubed. Saka zvineka kufanana but zvineka kusiyana, but principle yakafanana. Kunoku tichaita sei? Tichati okay, ticha subtracta kunoku, then twataisa kaline kanaka. Toti 6 minus 6 ndiani? Ndi 0. That is the same thing we are going to do there. Ticha subtracta kuno, but I encourage muva maisa bracket rinoi, moisa line. Moti x to the power 4 minus x to the power 4 ndiani? Ndi 0. Moisa ka dot, msaisa 0 isa dot. Mozoti 0x cubed minus plus x cubed. Maona zvandaita 0x cubed, it's a positive, satangoiti 0x cubed minus plus x cubed. Koroti panapa pari kusangana minus na plus, saka inge richi minus x cubed. Saka ndo yatiri kuwana pano after we do the subtraction. Kuno kutawana 0 after subtraction, uku tiri kuwana this. Okay, tikadzokera kunoku ndo patinozoti chi carry down 6. We are going to do the same, carry down. What are we carrying down? Minus 2x squared. Like this. Anditika? Okay. Tozoti kunota chitichi 3 into 6 ndi 2. Tichaita the same kunoku. X into minus x cubed ndi minus x squared. Andika? Tozoti sezvo kunoku tati zoti 2 times 3, 2 inoi times 3 ndi 6. Tozo subtracta tichwana remainder of 0. Kunoku tichaita the same. Anditi tichati and panapa tati x into minus x cubed tikawana minus x squared, then tichabva tati minus x squared times x ndi minus x cubed minus x squared times 1 ndi minus x squared. And then we are going to subtract. Minus x cubed minus minus x cubed zvakafanana nekuti minus x cubed plus x cubed kureva kuti panapa ndi 0. Minus 2x squared minus minus x squared zvakafanana nekuti minus 2x squared plus x squared, so it's minus x squared. The process is going to reiterate kureva kuti tichabva taita carry down minus 3x. Toti x into minus x squared the minus x times x the minus x squared minus x times 1 the minus x subtract saka bracket kedu minus x squared minus minus x squared the 0 because that's minus x squared plus x squared minus 3x minus minus x ndiko kuti minus 3x plus x which is minus 2x. Tichingona minus 2x toiteta carry down minus 2 x into minus 2x minus 2 minus 2 times x minus 2x minus 2 times 1 minus 2 subtract minus 2x minus minus 2x 0 minus 2 minus minus 2 0. Saka we have a remainder of 0 like this. Takadai so tinenge tatoita long division. Saka this is how long division is done. Kana takuda kunyora our final answer tinenge takuti therefore p of x is equal to then bracket ra x plus 1 our divisor then multiplying bracket ra x cubed minus x squared minus x minus 2 which is our quotient. Tikadai so tinenge tatopedza. So what I want to do now is I want to give you an example inenge ine yatinenge tishandisa a non-factor kuti muone how can we long division using long division, how can we divide a non-factor with a polynomial. But some might not understand what has happened panapa. What has happened panapa is simple. 4 dividing 2 is equal to 2. And so zvinongoreva pano ndezvekuti 4 inoi inenge equal to 2 times 2. So tikada kuzviisa in the terms of what we did apo. Basically tati p of x divided by x plus 1 is equal to x cubed minus x squared blah blah blah. Saka p of x inge equal to x plus 1 multiplying the quotient. So that's the mechanics of what has happened there. It's not a big deal. Saka in our previous example again we used a non-factor x plus 2. So that is what we want to do. But as I was going through this I feared trying to associate long division yamakaita primary ne long division is necessary for polynomials directly might be a little confusing. So in my next example where I'm going to use a non-factor and a polynomial, I'm not going to be trying to associate anything. I'm just going to do procedure as it is. Saka in my example number 2 we are going to be dividing p of x which is equal to, what is the p of x equal to? X to the power 4 minus 2x squared minus 3x minus 2. We want to divide it by, it's divided by x plus 2. And since takaita in our previous class, I want you to remember kuti remainder panapa takawana irichi 12. So dogonoti tikaita long division tinowana iri the remainder 12. That is what we want to do. So of course we are going to, we know that x plus 2 is the divisor. and x to the 4 minus, remember panapa pana x to the 4 apa pana x squared, saka pakati tichaisa plus 0 x cubed tozoendera hedu mberi minus 2x cubed minus 3x minus 2 like that. Then let us do the long division. X into x to the power 4, the x cubed. X cubed times x, the x to the power 4. Total for the x cubed times 2, that's plus 2x cubed. Subtract, small bracket, line. X to the power 4 minus x to the power 4, 0, we put a dot. 0x cubed minus plus 2x cubed, the minus 2x cubed. The moment I turn your minus 2x cubed, we bring down minus 2x squared. X into minus 2x cubed, the minus 2x squared. Sakapatita kutsogoza the same process. Minus 2x squared times x, the minus 2x cubed, and minus 2x squared plus 2, the minus 4x squared. Subtract like this. The other thing which I didn't want to say, but let me say it, we are bringing down only one thing to match up, because panapa we have 2 terms in our divisor. Saka tiruku tsisa only chunu 1 kuti tiite match up kuti patinozoti x into x to the 4 x cubed yacho painozo multiply everything inenge ichinoproduce 2 terms. Kana musina kunzwisisa zvandataura chero neni ndiri kutozvinza kuti handazvitsanangura zvakanaka, don't worry, just do as I do. Okay, line redu, minus 2x cubed minus plus 2x cubed 0. You are going to take note that there is going to be a pattern of the first 2 terms cancelling each other. Minus 2x squared minus minus 4x squared ndiko kuti 4x squared minus 2x squared kuroti panapa it's 2x squared. From that moment bring down minus 3x. X into 2x squared plus 2x. 2x times x, the 2x squared. 2x times 2, that's plus 4x, like this. Tuatati 2x squared minus 2x squared 0, minus 3x minus plus 4x, diko kuti 4x, like minus 3x minus plus 4x, the minus 3x minus 4x, which is minus g, 4, 5, 6, 7, it's minus 7x. Okay. Then from this moment, tovatakanda minus 2 panapa. X into minus 7x, that's minus 7. Minus 7 times x, the minus 7x. Minus 7 times 2, the minus 14. Subtract like this. Minus 7x minus minus 7x, the 0. But minus 2 minus minus 14. Sakafanana nekuti minus 2 plus 14, which gives 12. Saka the remainder 12 iyo ndiyo 12 ino yatawana as the remainder. Patakashandisa remainder factor theorems. Correct, our long division is correct. Saka remainder inge chibuda iri number kunoku. So the reason yataitira division with a non-factor kwanga kungori kukuratidzai kuti remainder inobuda yakaita sei. So this is the crux of what we wanted to learn today. Thank you and take care.